Hello everyone, and welcome to the third tutorial in the C Programming with Windows API series. In the previous tutorial, we discussed about preprocessor directives, and we've discussed about header files and libraries, and how to differentiate the two. So, in this tutorial, we're going to be talking about data types, storing values inside data types, and how to produce output through values in data types. So take note, I use the word values, I mean variables, but values are a more easier way to derive variables. And I'll tell you why in a second, but first, let's go ahead and open up Microsoft Visual Studios. I'm going to open up our tutorials folder, and I'm actually going to rearrange it a bit. The first thing I'm going to do is I'm going to open up the one folder which we've created. I'm going to take the tutorial 2 folder, Control X, cut, and paste it inside the tutorials folder. Now the reason I'm doing this is because using tricks which we've learned from the previous video, inside Visual Studio I'm going to reorganize our whole project such that every project that we're going to use from now on is going to be in one solution, so that if anything we can kind of reference back to it later instead of it being in multiple solutions. So minimize that, or rather, yes, minimize it. Open up Visual Studios. Now what we want to do is we want to go to File, Open, Project or Solution, go to the Tutorials folder, open up Tutorial 2, and click Open. Now, the next thing that you're going to want to do is you're going to want to rename the solution itself by right-clicking on it, click Rename, and just rename it to Tutorials. The project, rename it to 1. By right-clicking on it, rename, and just change it to 1. Right now, we're going to add another project to the solution, Tutorials. Simply by right-clicking on it, Add, New Project. We follow the same steps as we did before, Win32 console application. The location, make sure it's the same as the original project. And we're going to name this 2. We're going to click OK. We're going to have the wizard appear, tell us it's a console application. We're going to click Next. Select Console, uncheck precompiled header, uncheck security development lifecycle checks, and hit the empty checkbox and click Finish. So now it's created us another project into our solutions. We can now view both projects simultaneously. This is really good if you want to manage more than one application inside of one. Like let's assume that you're making a game. So a game would include the actual loader for the game, a bunch of map generators. You would have a bunch of personally, I wouldn't consider myself a game dev, but you would have a bunch of applications which load your sprites. You would have a bunch of applications which load or render certain objects on the map. But each of these certain applications would be inside one solution, which is your game name, and each one would have its individual project. So just look at it that way. So the next thing we want to do for this tutorial of data types, storing values, and producing output through variables is we're going to go to Source Files, right-click it, click Add, and click New Item. Highlight C++ or CPP file, and we're going to name it simply tutorial 3.cpp. So, from the previous tutorial, we learned about the include stdio statically imported library. So, or rather header file, I'm sorry. We're going to do the same and include that same header file, stdio.h. Okay, on a new line now, what we're going to do is we're going to type a function name. Now, hold that thought. Functions, we're not going to be talking about functions until the 7th, or rather 8th tutorial in this series. But just let's talk about one specific function right now. And that function which we're going to talk about is called int main. Okay? Int main is actually a type of function. So I'm going to type this right now, int main, and then I'm going to explain what it actually does or what it is. So int is a type of data type, okay? There are many different kinds of data types. Such data types include, I'm going to put my multi-line comments. Such data types include int, obviously, char, I'll explain all of them in just a bit, double, float. Now, then we can't forget about the unsigned data type, which can possibly include other data type values such as an int, a char, a void. Okay. So, and of course there is the void data type. There are other data types, but we're actually only going to be focusing around these data types right here throughout our tutorials or throughout the series. So first, let's start off with the int data type. The int data type it's kind of like a shortened form of the word integer. And now what integer is it allows us to store a whole number. Okay? So any number from 0 to 2,147,147,147. Don't ask me why it's this number, but if any of you have ever played a game called RuneScape, you will notice that the max stash or the max amount of cash that you can hold in your inventory is this specific number. And why, you may ask? Well, let's just put it this way. The developers, when making the gold stack, they were using an integer data type. And the integer can only go up to this point until something happens. Now, we're not going to learn about what happens if it goes past this number yet, but we'll learn about it in a later tutorial when we talk about buffer overflow, stack corruption, and memory leaks, in tutorial number 13. So now we have the char data type. So a char data type, what is it? Basically, a char data type is any character, but only a single character. Take note. A char data type stands for character, just like int stands for integer. Char stands for character, so you can have a single character assigned to a char. A, B, C, D. Take note, I'm not talking about all these characters together, only an individual character on its own. Okay, so you can assign any character to a char data type. Take note, a char data type can also hold a hexadecimal equivalent of any character. So for A, right, or rather, for the number 1, right, you can hold 0. Okay. Oops. So let me just, I think I actually just got a little bit too ahead of myself there. For now, let's just learn that char character can only hold A, B, C, or D. Okay? Any simple character. And how you define a char with a character is you put it around single quotes. So for a char, a single char, we can have it around single quotes. Okay? Now we have this unsigned value. What does this mean exactly? Unsigned can hold any single character. However, it can also hold, it's basically used as a storage device in memory. Okay? So what this means exactly, what is the difference between, let's say, unsigned int 1, right? Sorry, int 1 and unsigned int 1. So the difference is int is stored specifically right then and there. Unsigned int is stored inside a memory sequence. Let's just say, put it like that for now. Okay, and what is a void? A void is actually nothing. A void, consider it as just the actual word void itself. It's just emptiness. It's nothing, okay? So it can't store anything, and it can't return anything, okay? So it's just nothing. Just let's leave it at that for now. So we don't assign a value to a void. It simply returns nothing, and I'll talk about that in 1 second. So here we have the simple function called main. Now, for a console application, whenever the program actually runs, so let's say I run the exe file, right? Let's say let's just assume for the sake of compiling the actual exe itself, let's assume I returned 1 really quickly. So because it's an integer, it also, for every function, you have to return a specific value, except obviously void. You don't return anything. You return a value according to the data type, according to what kind of value to expect. So for a char, you would return like a single character. For an integer, you would return like any number from up to, that 2,147,147,147. So, yeah. And main is basically where the program will run from. So let's say I compile this application. So I simply click build. Okay. So I've compiled the application. This is the path on my system where the exe for this application is. So I'm gonna go right click on the project type, on the project itself, and I'm gonna go to open folder in File Explorer, which is gonna open this the folder of this project. Okay. I'm gonna go back to tutorial 2, and I'm gonna go to the debug folder. So the original folder, so you're gonna be sorry, let me just do that a little bit slower. When you right click on open folder in File Explorer, you get to this folder here. So the place where our actual application is located is tutorial 2 debug 2.exe. Right now we're in tutorials 2. So we're going to go to the tutorials 2 folder. We're going to go to debug, as you can see here, debug right here. And right here, oops, sorry, tutorials debug. So right here is our application 2. Application, the size 35 kilobytes, date modified, whatever, and we have the information about our application. So if we run this application, you just see really quickly a black window appears, nothing inside of it, because all this application does is it's an integer function called main. Now let me remind, the reason that I called it main is because when the application runs, it's expecting, since it's a console application, it's expecting the predefined function name main, right, to be there. So let's assume I called it GDD, okay? You notice here how at the at the compile time, when I've compiled the application, it gives me this error, LNK. So LNK stands for linker. I'll talk about that later on. 2019, this is the error code of the linker. Unresolved external symbol main. Okay, so basically what this is saying is it doesn't find the predefined symbol or predefined function main inside of our application. Hence, it can't actually compile the application at all. So for console applications, you have to set what's called the entry point, and you have to call this function main. That's the reason why we call it main. So here we have int main, and then we have two brackets, and what these brackets are basically parameters. So in these parameters, what it allows us to do is pass a certain value to the function. Okay, so let's play around with this a little bit. Notice up here, oops, I moved that over. Notice up here where it says debug, we're going to go and click release. What this allows us to do is the difference between debug and release, there's a couple of differences, but two main differences are that with release applications, you can actually, let's say, you can give this application to your friend, and it's going to link, or rather, how do I put this? It's going to package all the different kinds of libraries with your application when you're building it, assuming you've told the application to link the libraries directly. It's going to package all the libraries with it, so no matter what libraries you include inside the application, let's assume your friend doesn't have Visual Studio installed, he'll still be able to run it. But the thing with the debug is every library is included remotely. It's only included from your actual system itself. So if your friend tries to run this a debug compiled exe on his system, it's going to give him an error saying that it just can't run the application. So I'm going to change this to release. Then the next thing I'm going to do is go to the project name itself, go to Properties, go to this Project Properties pages here. This window is going to pop up. These are basically all of the properties that are tied to the project when Visual Studio prepares it for us. Sorry. Where we're going to go is we're going to go to first. We're going to go to C, C++. We're going to go to code generation. Now, basically, what this is this is the tab for like any option related to when the application is being built. So right here, we have this cool little header called runtime library, and the definition for this is it specifies a runtime library for linking. Right now, it's defined as something called a multi-threaded DLL. What this means is that all the libraries which are included in this application will be linked directly from your system. So this with the multi-threaded DLL, what it assumes is that your application is being delivered with the required DLLs. As we spoke about in the first tutorial, DLL is a dynamically linked library for it to run. But if it's not packaged with it, and let's say you give your friend just the application itself, the application won't run. We can make the compiler automatically link or import the libraries statically by changing this to multi-threaded. Now take note. Let's compare here. First, let's compare the debug version with a multi-threaded DLL. So this is assuming that all the DLLs are linked directly from your system. Okay, I'm going to build this right now, and I'm going to go back to right here. Yep, I got it. Oops. So tutorials. Oh right. So I built it as in the release version. I'm going to build it in the debug version. Okay. And oh, this is the wrong folder. Silly me. So the debug. So notice how the application size is 35 kilobytes. This is when all the libraries are linked directly from your system. So they're not actually packaged in the application. So let's take note of this number, right? Let's assume the debug build is 35 kilobytes, right? So now I'm going to change this to release, and I'm going to not make it link the libraries directly, but I'm going to link it from the system into the application itself. So it doesn't have to look for them on the system. And then I'm going to build it. So what do you think will happen to the application size? Well, yes, it's a little bit obvious. The application size will increase because now the libraries are linked directly into the application. So as you can see now, it's 74 kilobytes as compared to like before having the libraries be linked, where it's 35 kilobytes. So as you can see, it's much bigger. And it still operates and runs in the same way. You get a black window that appears with nothing inside. But now let's talk about variables. So let's say I'm going to define a variable called int, and now I have to assign a variable name to it, to int itself, the int data type. So I can name this whatever I want. And remember, with syntax, int is also a type of syntax that the interpreter is going to read. With syntax, we have to type a space after it, and then separated by the next parameter that it expects to take. So int, I want to define int as age, okay? So I'm 21, so I can define a variable called age as an int data type. Now the variable name is age. What this means is whatever I define age as, it'll save inside this variable. So whenever I want to use this variable inside this function, I'll always be able to reference it by age. So I'm going to now set an integer to this variable. So all I have to do is type age equals, just like you would with like a mathematical operation, like you have to set it equal to something, or it won't understand what it is until you set it equal to something. It'll just assume that it's 0. So we'll set it equal to 21. And notice how I end the line with a semicolon. What this does is it tells the interpreter that this is the end of that specific line, or rather, it's the end of this specific syntax, okay? It's not the end of the line though, however, because note how this is another piece of syntax, return 1, all it does is return the number 1 from this function main. I can actually type this on the same line, and Visual Studios won't trigger an error. But if I don't have this semicolon, as you can see right here, it's going to say expected a semicolon, and obviously if it says this on this line, and this line has a semicolon, then it's expecting a semicolon from the previous line. As you can see here, I ended it with a semicolon. You can end it with as many semicolons as you want, as long as you just have one, that's all it's looking for. So right now I set a variable called age to 21. Now I'm going to set a variable, a char, okay, called letter, okay, and I'm going to set it equal to, take note, a char variable has to have single quotes around it if it's just one character. Since it's just one character, it has to have single quotes around it. To have many characters, I'll talk about later in tutorial number 6, where we talk about pointers, and in that sense you will be able to have, or rather even in tutorial 5 where we talk about arrays, where you can have many characters inside one variable. But for now, let's say letter, I set letter to A. So now what I have done here is I've defined an integer called age, I set it equal to 21, and a char called letter, which I've set equal to A. So now, let's say I want to print 21 on the screen, like so that you can actually see it, okay? So what I'm going to do is I'm going to switch, rather, I talk about debugging in 15. Okay, so what I'm going to do is I'm going to include another library, okay? Include a library called stdlib.h, okay? What this library allows us to use is a functionality, is a function called system, okay? And basically what this allows us to do is, since we're working with a console, which is basically a command line, we can type command line parameters with the function called system inside of it. So don't worry about how this is done for now. Just know that if you want to see the output that appears on the screen, you need to have system pause like this. So let's actually make this right here, memorize this right here, as a template for every tutorial that we start or do from now on up to tutorial 15. It's going to look like this, okay? So just save this in your mind. Basically, it's an integer function called main with empty parameters. These squiggly brackets which open up the function. And take note, we can only put code inside these squiggly brackets in the function. If I put, like, let's say system outside of the squiggly brackets, it's going to say it's an error, and it's going to say this declaration has no storage class or type specifier. That's basically saying it's not being wrapped around any function, and it's like you can't have a function being defined on its own. You can only have a function being defined from a function. And the default entry point for any function is main. Sorry, the default entry point for any console application is main. So we can only start out from main. We can't just have a function on its own. So system pause, all it does is it pauses the console until a character is inputted by the user. So let's say I go back to my exe now and I run it. Now you can see that the window stops and it doesn't automatically close. It says press any key to continue. That's what the system pause command does. Okay? So press any key to continue. I press spacebar, and it closes the application. So now I'm just pressing Control Z to undo all the things that I've done, just to go back to what I had before. So now you can see we have defined these two variables. Let's say I want to print age out onto the console. Okay, what I can do is I can type a function called printf. What it stands for is print file, and I can open these parameters. Now printf takes either one argument. It takes either one parameter or more parameters. It can take as many parameters as you provide inside the first argument. Inside the first parameter. And I'll explain that in the next tutorial, rather in tutorials that follow. What I mean by that, I'll explain. Actually, whatever. I'll explain it right now. So what I mean by that is, let's say I have age. Let's say I just want to print age to the screen. I can't just do that, right? Because the parameter that it expects is a constant char parameter, and I can only print text here. So if I do that, I can do that, and it'll allow me to print text, right? But wait, how can I print an integer variable to the screen then? What I can do is I can type a wildcard identifier, which is basically like a special string that the printf function looks for to determine what variable will be replaced inside this string, instead of the string. So let's say I type $d. What this d does, $d, is it allows us to replace a integer, okay, with this $d. So I can put a comma now, and whatever integer follows will be replaced with the $d. Okay, so let me explain exactly what this does. Let's say I also surround these by like @signs. Okay, what this will do is it'll allow these @signs to be printed, but instead of the d, 21 will be printed, since I'm going to input age, the variable here, inside printf. So I'm going to compile this, build, go to my folder here, run the application. Now you can see here just like we wrote in our code, you see the @sign, two @signs, a space, and %d is replaced with age, which is equal to so %d is replaced with age, and age is equal to 21, and that's why we have 21 here instead of the $d. Cool, pretty cool, huh? Well, yeah. Okay, so now let's say I want to replace, I want to put the letter A inside of here instead. If I just put letter, here, look. If I put letter and I put $d, check out what the output will be. Oops, it's saying that I cannot open the file because I actually forgot to close it. So I'm just going to press any key to continue and recompile it. Now it won't give me an error. So I'll go back to that folder and run it. Now, the output is the number 97. You're thinking, I wanted A to appear. I typed letter and the output is 97. What does 97 mean exactly? So let me pull up an ASCII chart right here. And an ASCII chart is basically a character representation of letters. So like through hex. So there are different kinds of encodings. Okay. So encodings. Okay. So here we have the number 97. And as you can see, the decimal representation, decimal being an integer, representation of the number 97 is A. And because we forced a char argument into a integer type, it converts the the letter A into 97, which is the decimal representation of it. But what if I want to actually print the letter itself? What I can do is I can replace this with C. So if I replace this with C, oops, I forgot to close it again. Press any key to continue. Yep, closes. And then I build it. Okay. So now, as you see, I replaced it with C. C equals char. Okay. So as you can see now, you see two @signs and the letter A. Okay, let me close this now. We don't need this anymore. And so now I've also talked about unsigned ints. Now basically unsigned ints, we're not going to be using them for a while actually. They're a more intermediate phase of the Windows API. Like you won't actually be using them unless you're dealing with memory specifically. And that right now, memory is out of reach for our tutorials. We only get into memory from tutorial 6, which involves pointers. Okay, so that basically wraps up everything for this tutorial. Please comment below if you have any questions. If you like the video, just give it a thumbs up. And yeah, I'll see you next time.